chapter 5 on inverses. All right, so if I look at the book here, I don't want that, let's see. And I go to 512. All right, we are how to use a graph to determine the inverse of a function. Okay, yesterday we did it kind of algebraically and we didn't use the graph too much. We did a little bit, but we're definitely going to use graphs today to look at the inverse. Excuse me. All right, so in the last lesson, we started with functions and worked backwards to determine the equations of their inverses. Now you will focus on functions and their inverses represented as graphs. Use what you discovered yesterday as a basis for completing problems below. Okay, so obtain the resource page, which has these 3 graphs on it, and make a careful graph of each function's inverse on the same set of axes as its corresponding function. Look for a way to make the graph without determining the equation of the inverse first. Be prepared to share your strategy with the class. Part B, describe the relationship between the coordinates of a function and the coordinates of its inverse. Okay, what is the relationship between the coordinates of the function and the coordinates of its inverse? Use tables of the function and its inverse to show you what you mean. Okay, so I'm going to click on that resource page, which is linked in the classroom, but it's also here. Let's see if this is easy for me to use. Yeah, I can use this. Okay, let's make some tables, right? Yesterday we talked about making some tables. So on your paper, let's make a table for this. This is our function f of x, right? And our function is 1/2 x plus 3. It's a bad 3. Sorry, I have to move my bar out of the way. Okay, that's better. 1/2 x plus 3. Okay, and we have some points on here. So we have like, here's -6 is our lowest point, and then -5, -4 is on there. So it looks like -6, 0 is a point right there. And then -4, 1 is a point, and 0, 3 is a point on our graph. So we don't even have to calculate these. We can just look at the graph. 2, 4 is a point, and 5, 6, 7, 8, 3, 4, 5, 6, 7. So 8, 7. Plug that in to double check it. 1/2 of 8 is 4 plus 3 is 7. Yes. Okay, so that is our table, our XY table for f of x. Okay. What do we know about the x's and the y's for our function and our inverse function? Somebody unmute themselves and answer, please. What? Go ahead. You cut out. You have to repeat that, please.
Oh, I said they're switched.
Okay, so what are switched?
The x and the y.
Okay, the x and the y are switched, right? So, so if I put y here and x here, well, really it's x and y. We're just going to switch the x's and y. So we're going to copy all these y's. 0, and I want you to do this on your paper. 1, 3, 4, 7. This is the work you need to show on your paper. Okay, we're going to put the y's here, and then we're going to put the x. So with 0 goes -6, with -4, with 1 goes -4, with 3 goes 0, with 4 goes 2, and with 7 goes 8. Okay, so we just switch them around. And if we graph these, this should be our inverse, right? This is the inverse right here. Inverse, which we use this notation that we learned yesterday or last class period, f -1x, f, we call that f inverse x. Okay, we don't say f -1x. So 0, -6, let's graph that. Here's 2, 4, -6 is down here. So the inverse of 6, 0, -6, 0, right? The inverse of this point is 0, -6. And then the inverse of this point, 1, -4, or -4, 1, is this point, 1, -4. So 1, -4 is down here. So you're graphing that. And then we have 3, 0, which is on the x-axis, 3, 0. This is why it's good to label your points. They didn't label enough points on the graph. 4, 2, so 4, 2 is right here. And 7, 8. 7, up 8. Okay, and hopefully you're graphing these successfully on your paper. Okay, let's make a line through these. So I'm going to draw a line through all our points, and I have a nice ruler on my drawing app. Hopefully, are some of you using a drawing app now that I showed you I explained how to use it? It's a little crooked, but oh, I guess I could have used this with an arrow on it. Look at that, fancy arrows. Now I'm fancy. Okay. Okay, do you see the inverse, how it's related to the original graph? Okay, let's see, is there anything else I'm supposed to answer with that? I have to erase this, unfortunately, but you know what? Let's see if I can take a screenshot of it. I think it's letting me take a screenshot because I don't want my ink to go away. Let me go ahead and open my 3D. See if I can, it won't let me do this because let's see, my 3D, I'll show you what 3D Paint looks like. 3D Paint is awesome. If you haven't used it, man, free advertising. It's usually free in your Windows suite. So if you have a Windows thing, so here's my picture and there's the other writing, but the other writing won't show. And then I just Control V, I Control copied and then Control V here or screenshot it, and I can save it so now I could turn it in. What do I want to label this as? What is this? Problem number 17? 5-17. Let's see. It lets me save it as and I don't want to save it there. I want to save it under, let's do math 3, period. I'll just put period 4, save. Okay, so that's one way to save your work, right? Because I'm going to erase all this stuff, so that's why I had to save it. So now I got to go back to my screen. Where was I at? Right here. Okay. All right. So I need to erase this stuff. And so I need to go to annotate. Should have erased my stuff before I did that. Okay. So that was the first graph. Now we need to go down to the second graph. So I need to scroll down. Okay. Oh, now we have a quadratic, a parabola. Okay, we're still going to do the same thing. We're going to make a XY table. So let's do that. XY, our function is this. We could plug in numbers, but we don't have to because they gave us graphs, and I don't like how they just number to 5. That's very confusing. So add some numbers. So you see that the vertex is at -2, -6. So we're going to put that in the middle. You always put that in the middle, -2, -6 when you do your parabola. And then your other points are at, this is -1, -2, -3. So -3, -3, -3, -3, and -1, -3, because it's symmetrical, is that point right there. And that means at -4, we are going to have 6, right? That is 6. -4, 6, and 0, 6. So we easily had 5 points because they were graphed for us. This is our f of x function. So can we make a f inverse of x inverse, right, table? And I don't know if I want to put yx. I'm just going to put xy, but we know we're going to do what with these, you guys? We're going to swap them, right? So I just put the y column and the x column here, and I put the x column and the y column because this is the inverse of that. So -4, -3, -2, -1, and 0. Okay, so we have switched. So this is the table for the inverse function. All right, so let's graph these points and see what we get. So 6, -4, here's 6. -1, 2, 3, 4 is right here. That's that first point. Our second point is -3, -3. Okay. -3, -3 is going to be the same point right here. Okay. Then -6, -2, that's all the way over here. -6, -2. Okay, and -3, -1, -3, -1 right here, there, and 6, 0, which is right here. Okay, do we see our graph? Do you see what's happening here? This is going to be our vertex because it's in the middle, right? You see it's symmetrical right here. So let's go ahead and draw a parabola. It's supposed to be like U-shaped, not V-shaped. Okay, it is a parabola, but it's a very narrow parabola. It's not V-shaped. It is actually U-shaped. So we have a sideways parabola, right? A sleeping parabola. So is that always going to happen? Anytime we have a quadratic, we have a parabola. Is it the same parabola, but just flipped over? Is it?
Yes.
Yes, it is, right? Because this has a slope of over 1, up 3. So we're going up 1 over 3. So it's the exact same parabola. It's just flipped over. And I want to say it's not a 90-degree rotation, but it's kind of like a 90-degree flip, right? I don't know does that make sense to you? And where are we? Yeah, later on, we're supposed to do, where's the line of symmetry? There is a line of symmetry through here. Does anybody know where the line of symmetry is? Where we would draw it?
Yeah, it's diagonally through like almost through like 0, 0, like in between negative -3 3, I think, and
right here.
-1 just right where they intersect. I think that's supposed to be, yeah, that right there.
Right
yeah.
where they intersect, right here, right? Okay, good.
Not y equals x.
Okay, how did you guys know that? I'm very
I kind
interested.
of just tilted my head sideways and I was like, oh, hey, it's the same.
Okay, so you just tilted your head sideways and you figured out this is the line of symmetry right here?
Yeah.
Okay, well, that's awesome, you guys, that you guys figured that out. Okay, so no, this is the line of symmetry, so please draw it in your paper. And this equation, this line has an equation, right? What is the equation of this line?
Y equals x.
Y equals x. So, if we made a XY chart for Y equals x, it'd be -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, right? The x's would mirror the y's because they're equal to each other. And this is the 45-degree line, right? It splits the x and y axis in half. And notice what happens in where do these graphs intersect? There's 2 points where these graphs intersect, right? Where this point right here is on this parabola and that parabola. And then this point is on this parabola and it's on that parabola. And that is the point, we don't know what point that is because it's a decimal. But we do know this point was -3, 3. That was on the graph right there. And it was right here too. Okay, so points that have the same coordinates that are on the graph will be on the line of symmetry. Okay, and when the graph crosses the line of symmetry, so like when this graph crosses the line of symmetry, that's going to be a point on the other graph too. That always happens. Isn't that cool? So like where this line crosses, this parabola crosses the line of symmetry, that's going to be a point on the other graph too. Okay, so and then this parabola is going to cross the line of symmetry right here. So we had that point supposed to go right through there. I made it a little low. Okay, so oh, it didn't cross there, it crossed here. That's not part of the line of symmetry. So yeah, so anytime the graph hits the line of symmetry, there's going to be another point on the other graph that goes through there. Okay, and I think this is the graph that Ms. Holly says this makes a heart, and this is your Valentine's for whoever you want to give it to, your parents or somebody. She said this makes a heart, so you could give it to them for Valentine's because that's coming up. Is that this weekend? I think it is, huh? I think I need to get something for my husband. I don't know what. Maybe I'll give this to him. No, I'm just kidding. All right. Okay. So I think we learned a lot from this graph, right? I think we learned this is a line of symmetry. Is this always going to be the line of symmetry when we do inverses? Let's see. Let's do the next one. Okay. I should take a screenshot of this one, but I'm not going to because I don't want to. Okay. So let's do the next one. Scroll down here. Oh, we got a cubic. All right, this is a cubic equation. Cubic. Why do we call it cubic? Because it's got a third power. A cubic equation, if you remember, has different end behavior. One section goes down, there's an arrow down here, and this goes up forever. So a cubic goes like this, right? The regular cube just goes like that. But when you start throwing other terms in, then it bends more and it does that thing. Okay, so can we make an XY table? Absolutely, we should. You must make an XY table. This is showing your work, right? We'll put f of x, telling me this is the original function. And let's see some points on here. So we have -1, 2, 3. This is -4, 0. So -4, 0. Notice I start on the left. And let's go to -3, 4. And then we go to -2, 5. And then back down to -1, 4. And then to 0, 2. And then to 1, 0. And then to 2, -1. And then to 3, 0. A lot of points here. This is good because you need a lot of points because there's a lot going on in this curve. So you can't just use 3 points. You can't even just use 5 points. You need more points. So we did 3, 0. So 4, 4. 4, 4 is a special point, right? I already know what about 4, 4, you guys. That it's going to say again?
It's going to stay the same.
Right, and it's going to be on the line of
Symmetry.
Yes, exactly. Exactement. All right, XY, F inverse of X. So what do I need to do with this table, guys? Let's do it. Let's switch it around. I'm going to write the Y's underneath the X's. 0, 4, 5, 4, 2, 0, -1, 0, 4. It's easy when it's right next to each other, and I just copy that. Now these go in order, so that makes it easy. -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, so let's graph this and see what it looks like. We could put a line of symmetry in there. Maybe I'll do that later, or I can do it first, but let's just do the graph. 0, -4 is right here. That is the reverse of -4, 0, right? So these are the reflections of one another right here. Now let's do 4, -3. 4, -3 is over here. That is the reverse of this. So that's the reflection of this one, right? That's the reflection. Now let's do 5, -2. 5, -2. That is the reflection of -2, 5. -2, 5, that one right there. 4, -1. Let's see, 4, so it comes back because we have -1, 4. So those two are reflections of each other right there. And then 0, 2 will be 2, 0 right here. These two are reflections of each other because if I draw this line right here, look what point it goes through, 4, 4, right? Just went through 4, 4. I could draw it going through here. It's easy to draw this line because you draw it through the corners of the squares. Okay, where did I leave off? I left off on 2, 0 right here. So now let's do 0, -1, or 0, +1. So 0, +1 is right here. That's the reflection of 1, 0. Then -1, 2. -1, 2 is the reflection of 2, -1. So those are 2 reflections across this line. 0, 3 is up here. So we come back up here. That's the reflection of 3, 0. So these 2 are reflected. Okay. And then 4, 4. Lastly, 4, 4 is this point right here. So it's going to go through the point that's already there. Okay, can you see the graph? Can you make the curve? I see a nice curve right here going like this. And then coming back up here. And then back down here. Make a smooth curve, please. Please do not. Oh, and it should cross through here. Even though this isn't a point, since the line of symmetry crosses like right here, I know that's a point too. Okay, oh, this is the heart. Ah, I definitely see there's the heart right there. That heart, this is your Valentine's, guys. There, you made a card. Just color it in and give it to somebody. All right, so you see this, the curve is the sideways curve. So the curve was like this. Now it's sideways, you tilt your head and draw, make sure you draw the line of symmetry in there. So you show us, oh, okay, so there's a couple of points. There's this point on the curve, there's this point on the curve, and this point where all 3 cross the line of symmetry. Those are going to be points on both of the graphs. All right, yeah, it's pretty neat, huh? You like this? I think it's pretty cool. Okay, so you can either take a screenshot of that and, you know, turn it in for your classwork. And I have to erase this and go on to the next problem. Unfortunately.
Wait, one moment.
Oh, you're lucky because I accidentally didn't press the erase button yet. Here, let me take a screenshot online since you made me stop. And I'll put it in my 3D menu. New. Have you guys used 3D Paint before? Anybody use it? Do you guys have it? How many of you have it and didn't know you had it? Put it in the chat for me. Just put, I have it and I didn't know I had it. Just put, I have it. Put it in the chat, please, because I'm happy to know if I showed you something new. 5-17C. Save it. And it's really easy to save. So you guys all knew about this because nobody put anything in the chat. I told you nothing new, huh? Does anybody like?
I didn't know anything.
Do you have it on your computer?
No, I have a MacBook Pro.
Okay. Well, oh, then you definitely have something like this. It's just called something else. Okay, great. Awesome. Yeah. If you have an iPad, man, you're for sure any kind of tablet you can draw on, right? Because if you can touch it, then you can draw stuff. So even your phone, like if you have a Samsung Note or any drawing apps, you know, you can use this to, but it's just a small screen. So it's hard to do on a small screen. All right. I'm into art. I love art, guys. So I love drawing. I love my Apple Pen. I have an Apple Pen. I have a tablet for my laptops that that's how I draw stuff on here. And I just love art. I draw like to relieve my stress and escape the madness of life. All right. Somebody wrote something else in the chat, so check it out. For a Chromebook, you can't have a download, you can't download apps right there. So it'd have to be like a Chrome extension, which I think there is. I heard there's Google Draw. You could do Google Draw. So there's probably an extension for that if you're using a Chromebook. Cami, right? You use Cami to draw stuff. So you can use Google Draw. You can use Cami for Chromebooks. I think, does the Cami extension work on Chromebooks, guys? It slows down my computer a little bit, the Cami extension. So, and it doesn't work well with my tablet, so I can't use it. So I use my other devices though. Yeah, it's harder on a Chromebook than, oh, that's why laptops are more expensive because you can do more stuff with them, and iPads and stuff too, and MacBooks and all that stuff. But you can do it. It's just you have to look more. And I don't use a Chromebook, so I don't know for sure. Okay, okay, so we did 15, 16. When you look at the graph of the function and its inverse, you can see a symmetrical relationship between the two graphs demonstrated by a line of symmetry, right? We found that line of symmetry, right? We know what it is. Draw the line of symmetry in each of the graphs. Okay, we did it in the last two, so you could draw in the first one. Go ahead and do that. What is the equation of the line of symmetry for each graph? So for number 16, we're going to name what that line of symmetry is, right? This is part B. Line of symmetry is always y equals x for inverse functions. Okay, it's always going to be y equals x, that diagonal line that goes through 0, 0. It always goes through 0, 0. It always goes through 1, 1, 2, 2, 3, 3, 4, 4. That's how you know where to draw it. It's where the x and the y are equal to each other. Okay, so hopefully you learned that today. That's important. Why do you think this line makes sense as the line of symmetry between the graph of the function and why does that make sense? Because what did we do to find what did we do with our table? It makes sense because don't we switch the x and the y?
You swap the coordinates. Yeah.
Yes.
Yeah, because we switch x and y, and therefore when we switch x and y, the x and the y are equal when y equals x, right? It makes sense because we switch x and y, and yeah, so y equals x is if you switch them, that's where they're the same. So that makes sense. That's the line of symmetry. Okay, 17. All right, this one, you need a piece of graph paper. I hope you have one full sheet of graph paper to use because it says to use a full sheet. And I did this and I needed a full sheet. Okay, so the whole front side of one or the whole back side of one piece of paper. So hopefully you have graph paper. Make a complete graph of y equals x over 2 squared. So x divided by 2 squared. We're going to write that down. Use the same scale for the x and y axes. So I went by 2s. And so I went by 2s on the y-axis and I went by 2s on the x-axis, and you have to go down. You have to use all 4 quadrants, okay? Because you need to get to like 25. That's why I went by 2s. So I actually went to 26, right? My graph goes to 26. Actually, it just barely fit. It just barely fit to 25. On the same set of axes, graph the line of symmetry y equals x. Trace over the curve. Okay. Y equals x squared with a pencil or a crayon. So hopefully you have like a pencil or a crayon, probably a pencil. And you can't use pen because it's not going to work if you use pen, unless it's a real inky pen, but pencil will be better. Trace over the curve in heavy and dark. So like trace it really heavily, okay? Trace the curve and then fold your paper along the y equals x. We're going to fold our paper along this. And then you're going to take your thumbnail and you're going to scratch it so that the image, and so we're just going to get some kind of parabola like this, right? Because this is a quadratic equation. You're going to take your thumbnail and you're going to fold it over this line, and then you're going to scratch it so that this part transfers over here and this part transfers over here. Okay, and just scratch it. Take your thumbnail and just scratch it back and forth like a scratch and sniff, or you could take like a coin or something, or just your thumbnail and just scratch over it so that it transfers. It's called a carbon transfer, right? You transfer your drawing onto the other side of the paper and then open it up and see what you get. Okay, so let me clear this away. I did this earlier, so I'm going to show you a picture of mine. If I can bring it up here, let me find it right here. Picture. Okay, so first of all, let's make a table. Okay, so let's make a table. So this is 5-17 on it. Here, let me draw on here, 5-17. Let's make a table. The equation was, I need to move my little bar here. The equation is this right here, y equals x over 2 squared, right? Write that down, make a table. At first, I just put these numbers on my table, but then I realized I needed more. This says -4, 4, -2, 1, 0, 0, 2, 1, 4, 4. But then I realized I needed, that just gave me this, and I wanted a bigger graph. So I put -10, 25 on there, -8, 16, -6, 9, +6, 9, 8, 16, 10, 25. And I could have spread it out better. Okay. In other words, I should have put it like this. You can write it like that if you want to, but I should have put -10, -8, -6, -4, -2, 0. Why did I only use even numbers, guys? Why did I just choose even numbers? Because what is the function doing? You're dividing it in half, right? So wouldn't you pick even numbers if you want to divide something in half so you get whole numbers? So that's why I picked even numbers. And for this, I got 25. For this, I got 16. I got 9. I got 4, 1, 0, 1, 4, 9, 16, and 25. Okay, go ahead and graph those. Go ahead and graph those to make your graph. Take a minute, make it nice, make it big. There's no little graphs. I went by twos. I had to go by twos. Okay, I went 2, 4, 6, 8, 10, 26. And then I had to go to, this one only needs to go to like 12 over here, but it needs to go to 25 over here. And it needs to go to like 12 down here, I think. So this goes to 12 and this goes to 12, but this has to go to 25 and this has to go to 25 to fit everything. And I went by twos to accomplish that. Let me know in the chat when you're done graphing it, so I can move on, okay? But I'm gonna leave this up there so you can draw it. And don't draw the inverse. I accidentally drew the inverse, you know. What I did is I like reversed these, right? I reversed these, but don't draw it on there. This is where we want you to fold your paper. So draw the line y equals x. I put 0.11, 22, 33, 44, 55, 66, 77, 88, 9, 10. And I made a nice line of symmetry there. Right? And then fold your paper. Once you draw this parabola, fold it in half across the diagonal right there. And then take your fingernail and scratch it over. But do not draw the red parabola in, okay? Don't draw that one in.
So we're actually gonna like fold our paper.
Yes, you're actually physically folding your paper in half. Yes, I can't show you that because, you know, I don't have a live camera. But yeah, you're folding your paper in half. Okay, so I just labeled all the points while you guys are doing that, just so to give an idea of where they are. 1% I think is done. Do we fold it vertically or horizontally? Nope, you don't fold it vertically or horizontally. You fold it diagonally down this line. Since this is the line of symmetry, you need to fold your paper down the y equals x line. And then, so this part is going to be on top. This part needs to be on top. Take your fingernail and scratch it really hard over your line. Hopefully you can see your line. You need to trace this parabola really dark in pencil, and then fold it over the blue line. Make sure this part is on top. Take your nail and scratch it over so that it makes this, so it makes the red graph. So it transfers onto the other side of the paper and it makes the red graph. It's not going to be red, it's going to be pencil. How many of you were able to do that? If you're able to do that, please put in the chat that, yeah, you got that. Like you folded it over the blue line, you scratched your fingernail on top of it so that you got this image on your thing. And you're going to take a picture of this and show it to me, right? You're going to take a picture of this when you submit your classwork, and I want to look for this, that you did this. Okay, good. Jack got it, and so far he's the only one who's confirmed he's done it. All right, Nala got it to work. All right. Sierra got it to work. Good. Yes. This is like math 2. Remember when we used to take the tracing paper in math 2, and we did something like this in math 2 last year? All right, good. 3 people have confirmed that they got it. They did it. Okay, so you fold it over the blue line. You take your thumbnail and this part is on top, and you scratch over it, and then you'll see this part appear on your paper, right? It's kind of like magic. It's pretty cool. Good. Elizabeth got it. Ethan got it. Good job. So you're folding the blue line. Somebody asked me in the chat, you don't fold the black line. The black line is a curve. So you have to fold, yeah, this blue line, this y equals x. Okay. All right, good. Did Ari write that? You got it? Let's see. Oh, so you're folding, yeah, folding across the blue line, scratch your thumb over the black line, and it'll make the orange line. All right, guys. So I'm looking forward to seeing those when you take a picture of those. We've got a couple more problems to go over that are really quick. Let me get out of here and go to back to the book. Back to the book. Let me erase my work. Where's my pen? There we go. I got to erase that drawing. Okay. And scroll up. So that is number 17. Okay. When you open the paper, you should see the graph of the inverse. So after you scratch it, you open it and you see the graph of the inverse. And you can read this. If you're having problems with this, read this on your own. Okay. We're going to move on to 18 and 20. Now you will look at the relationship between the domain and range of the function and its inverse. What are the domain and range of the original function y equals x squared? What are the domain and range of its inverse? Okay, maybe I shouldn't have erased that, but that's okay. I'm gonna go like this. So the original function was just a parabola like this. So the domain, right, 5-18, the domain is what? If it goes forever this way and forever that way? All real numbers, right? All reals. All reals. Our range, it doesn't go down forever. It only goes up forever in this direction, and it stops right here. So our range is y is greater than or equal to 0. Okay, for our inverse, which went the other way, the inverse just went sideways like this, right? For the inverse, the domain was from here to the right. It stops here, it starts here, and it goes to the right. So the domain is x is greater than or equal to 0. And the range, how far up, and it goes up forever and it goes down forever. So the range is all reals. So is there a relationship between this domain and range and that domain and range, between the function and the inverse? What's the relationship?
They're just flipped.
They're flipped, they're swapped, right? Good. This range becomes your domain now, but you do want to change the y to an x, right? So it's still greater than 0, but this is going to be x is equal greater than 0. And this all reals became this all reals for the y. And that makes that it switches. It makes sense that it switches because we switched the x and the y's. So the domain and the range are going to switch too. Okay, so for part B, domain and range switch for inverse functions. Okay, the domain and range switch for inverse functions. So that's an easy way to come up with your domain and range. You are going to be asked this on the next test too. Okay, number 19. Your graphing calculator can also help you. And it says to skip 19, but you can do this on a graphing calculator, guys. And so I know some of you have graphing calculators and we haven't been using them a lot. Just YouTube it, Google, do a search on YouTube on using the inverse drawing feature. So if you YouTube search inverse drawing feature graphing calculator or TI, whatever you have, 83, 84, it doesn't matter what you put. Or inverse draw feature graphing calculator, you will find a bunch of videos on how to do this on your graphing calculator, and it'll show you like, oh, the two graphs. So there's a dedicated button on your graphing calculator that will help you do it. Okay. Well, you don't just fold the paper, you have to scratch the paper. So if your curve isn't showing up, you have to fold it and then you have to scratch on top so that the pencil transfers from the top of the paper to the bottom of the paper. Okay, if you're having trouble, you have to scratch your finger on top. Okay, let me erase this work. So we don't have to do 19. That's just saying, hey, you can do this on your graphing calculator. Last one we're doing today is 20. The rest we're going to do next class period, next Wednesday. 20, write the equation of the inverse y equals x squared, x over 2 squared. Is there another way to write it? If so, show how the two equations are equivalent. Demonstrate that your inverse equation undoes the original function. So our original function was this parabola. X over 2 squared is a parabola. The inverse function we know goes sideways. What is the equation of the inverse function? So how do we find the equation of the inverse function, guys? We talked about this last class period. What do we do? 2 steps. What do we have to do?
You switch the y and the x.
Good. We switch the y and the x, right? So we put x equals y over 2 squared. So this is one of the this functions. So this is one of the answers. Okay. Or we can undo all this. We want to actually solve this for y. So to undo this, what should we undo first? We should take the square root to undo this squared, right? If I take the square root of this side, I want to put plus and minus when I take the square root over here. So I'm going to get positive and negative square root of x equals y over 2. Now we want to get rid of the 2. So we are going to multiply by 2. Multiply by 2. Now when I multiply this by 2, I want to put the 2 in front of the square root. So it's positive and negative 2 times root x equals y. So this is the equation of the inverse. So the inverse of this parabola that we did, which was this sideways parabola, remember the square root function goes like this. It goes like that. And so to get the bottom half, the positive is going to give you the top half, and then the negative is going to give you the bottom half. That's why you need a plus and a minus. If you don't have that minus, you only have the top half of the graph. Okay. When you input this into your graphing calculator, you need to input 2 separate functions. You need to input 2 root x and input a second function of -2 root x to get the whole graph. You can't input it all at once. So you have to input both of these into your graphing calculator to get the inverse function. Okay, you can't do plus minus like that. All right, so those are the equations of the output. How could we show this is true? We could graph both of these on a graphing calculator or Desmos, and then graph this one. You can graph this one on Desmos, x equals y over 2 squared. These are both the same, right? But on a test, we're going to tell you to fully solve it and do this. Okay. All right, guys, that is the end of our second lesson on inverses. We're heading towards logarithms. We're not ready to do logarithms yet, and that's good because we still need to just tighten up our skills on inverses before we do logs, okay? So we're going to continue next week on Wednesday with 21 on. Your homework, let's see, your homework is your classwork here. Your homework, I didn't mean to move that, is, won't let me click on it. Those probably is 27, blah, blah, blah. It won't let me click on it here. I don't know why it does that sometimes, but here, let me, oh, there it is. 25 through 32, skip 27. So make sure you turn in your classwork. I need a picture of the 3 graphs from the resource page and the other graph, the full page graph that we did. Oh, 3 people already turned it in. Awesome. So, well, 4 people turned it in.
All right.
So
Have a happy Valentine's Day, Miss Wakefield.
thank you. You too. I appreciate it. Let me